Everyone, it's 12:30, and I'm going to go through some examples today. So I just start this lecture. Before I go through the materials, do you guys, any of you have any questions? Everything's clear? So we're going to have makeup, homeworks, and quiz tonight, and we had that last night too. So 4 to 6 p.m. in this room, ran through 111, homeworks 1 to 3, and quiz 1. So if you missed any of these, or if you want to increase your grades, this is a good time. Any questions about this? And I keep repeating this, and I just want you all to know that if you have any questions or any problems with this course, just contact me. And I have some of you that contacted me, and I scheduled like tutoring sessions with you. And I make sure that you understand the course materials, and if you tell me that you want to succeed in this course and get A's or B, I make that happen, okay? But, sometimes I tell students that, as long as you care about this course, you get a good grade. And sometimes the students think that caring means like doing nothing about chemistry and just like wanting to get a good grade. That's not the case. Caring means to email me if you're struggling in the class, and I schedule tutoring sessions with you. I study the materials with you. I make sure that you succeed. But I should see that you care. Does that make sense? I want everyone to get good grades in my course. But as I mentioned last session, some of you are not. And the reason is that probably you're not putting the effort. For each lecture, you should study 1 hour at least at home. So you should be studying at least 3 hours per week. And if you don't have the time, if you cannot do that, and you're not getting good grades, I encourage you to just drop the course, because I don't want to decrease your GPA, Does that make sense? And again, remember about the mask policy, to have, wear your masks completely, so students sitting next to you, they won't be uncomfortable. Sometimes they don't want to talk about it, but they won't be comfortable, okay? Any questions or concerns? And if you cannot meet a deadline for homeworks or quizzes or exams, just let me know beforehand so I schedule makeups for you. Again, I tell that all the time in my classes. If you're sick, whether emotionally or physically, and you cannot function, your daily life activities, I don't want you to do my homework, obviously. But you should communicate that with me in advance, before the deadline. If you communicate that with me after the deadline, I cannot do anything about it, because you have like 1 week at least for your homeworks and quizzes, so you should let me know in advance. Does that make sense? Any questions? Okay, and again, I emphasize that because we have a big classroom, and I need to focus what I'm telling you, and I want all of you to focus. If I see people, they're talking or laughing, I'm going to ask them questions. So if you don't want me to call on you, just, pay attention. Okay. So we're going to continue talking about chapter 3, which was matter and energy. Can anyone tell me what was a matter? Anyone? Is light a matter? Why not? Exactly, it doesn't take space, it doesn't have a mass, right? So there is. So again, I really emphasize on this slide because it's really important. Make sure to know the definitions because you're going to see them in the exam. And I also really emphasize on periodic table because that is, a building block of this course. This is kind of like, alphabet of what we are studying. Can anyone tell me the elements that we learned last session? They were like metals, yes?
Rubidium, cesium, and francium?
Exactly. So we talked about, elements in group 1A. I told you guys that hydrogen is the lightest element, is a gas, right? It's not a metal. But except hydrogen, the rest of these elements here, they are metals. Lithium, sodium, potassium, rubidium, cesium, francium. And we talked about this last session. They are in group 1A. In your exam next week, I'm going to give you elements in periodic table and ask you what is the row number, what is the group number. And I give you the periodic table. And I expect you to be able to locate the elements. For instance, if I tell you let me just give one of these guys. So if I tell you chlorine, what group is it in periodic table? What is it? Exactly, yes?
So would you mind if we referred to it as 17 rather than 7A, or do we have to refer to it as 7A?
So you should know both. So whichever you're more comfortable, but you should know both. Because in the question, I may ask you one of the answers can be 7A or it would be 17. And again, you have the periodic table, I'll give you that. But even if this 7A is not written here, 17 only is written here, I expect you to know that the main group elements, and as we progress with the course, now I tell you that these elements here in group 1A, 2A, 3A, the ones that have A's basically, these are like main group elements. The ones that have these guys that I just specify here and here. Great question. Any other questions? And if I tell you what period chlorine is located at, what would you say? 3, right? You have the horizontal line, and then you report this number that I just smashed here, 3, right? This is 3. Or if I asked about nitrogen, which period is it in? 2, exactly. You go here, you read this number. So the period or row is 2. What is the family or group number for nitrogen? 5A or 15. Does that make sense? Any questions? So now, this session, I want to talk about metals in group 2A. All the elements in group 2A are metals, okay? And I tell you about the first 3 ones: beryllium, magnesium, calcium. Probably you heard of calcium before, right? In daily life. The other ones maybe, maybe you heard of magnesium too, but maybe not beryllium. So remember, beryllium, magnesium, calcium, they are located in group 2A or 2. Okay? So next session we're going to review these again. But so far, any questions? Good. I'm going to continue with the lecture that I was giving on temperature. Can anyone tell me if I have an object that is really hot and an object that is room temperature? So one of them is 100 degrees Celsius, the other one is room temperature, right? So in which one the motion of molecules are more? Yes?
The hotter one has more molecules.
Exactly, because as the temperature increases, the motion of molecules or atoms becomes more, okay? So the temperature increases. So thermal energy temperature is an indicator of the thermal energy that substances have. Do you remember, based on what we said last session? So what happens if the atoms and molecules, they don't have any motion? If they're just like still, if they don't move at all, what temperature would be having? Yes?
0 Kelvin.
0 Kelvin. Remember, 0 Kelvin is the coldest temperature possible, because at that temperature, all atomic motion would stop. So the atoms or molecules, they won't move anymore. For that matter, the temperature would be the coldest, okay? So I ask this question always in the exam, and almost 90% of the students, get that wrong. I say, which temperature is the lowest? And I gave like 0 Kelvin, 0 degree Fahrenheit, and for Kelvin we don't write degree, just like how we agree on writing them, or 0 centigrade degree, or degree centigrade, and I say the last one, so this is A, B, C, D, and then D, I say all of the above are 0, so they are like the lowest temperature possible, So if I ask you which temperature is the lowest, which one would that be? 0 Kelvin. Did you want to say the same thing?
Yeah.
Okay, great. So 0 Kelvin is the lowest temperature possible. Although, all of them are 0, don't get confused, because there are different scales, right? It's kind of like, for some quantities, if we have 0, it would be the same. If I say something is like 0 meter, it also would be like 0 inches, But for temperature, because we have like, addition and, subtraction involved, the temperature 0 Kelvin won't be the same as 0 centigrade. Does that make sense? And I'll go through like some examples after I finish with these slides. So remember, or I can ask you which temperature is the lowest, and I say 20 Kelvin, 20 centigrade, 20 Fahrenheit, and the last option would be all of them are the same. They're not the same, okay? So here, we learned about like degree Fahrenheit, Celsius, or, centigrade, and also Kelvin. And remember, the base unit of temperature was Kelvin, remember? I asked you guys, in your exam that what is the base unit of temperature, and it would be Kelvin. Kind of like what is the base unit of length, it would be meter. Remember previous lectures? Okay, so absolute 0, which is basically 0 Kelvin, is the temperature at which molecular motion virtually stops. There is no lower temperature. So if I tell you, is the following statement true or false? We can have, a temperature. Scientists did some experiments at minus 10 Kelvin in the laboratory. Is this sentence true or false? False. We don't have any negative Kelvin, right? This is like 0 Kelvin. It's the lowest possible. We cannot have like negative degrees in Kelvin. But we can have with centigrade and Fahrenheit, as you can see here. And this is how we convert these scales with each other. And I want you guys to remember these formulas. So if you have like degree centigrade and you want to convert that to Kelvin, you add 273.15 to it. And if you have Fahrenheit and you want to find centigrade, you have, you deduct 32 from Fahrenheit and divide that by 1.8. Or you can write this as like 1.8 degree centigrade plus 32 equals degree Fahrenheit. I want you guys to remember these two formulas. Remember, I told you I don't ask you to remember any numbers unless I tell you so. So this is one of the examples that I want you to remember these formulas. I give you temperatures to convert, and I don't give you the formulas. I expect you to remember. Any questions? And one way to remember the formulas is that if you just remember this number here, 273.15, or if you remember the order of the number, that it was 270 something, okay? And you don't remember which one was it. Was it like was it like Kelvin equals like degree centigrade plus or minus? If you didn't remember, if you have like, if you put, you know, minus here and you put like 0 centigrade, you will be having negative Kelvin, okay? So remember, you're not having any negative Kelvin. So this is one way to remember, okay? Any questions? Good? Words. Okay. So one thing that I want you guys to know is that if we have like different substances and we heat them, some of them would heat up more quickly. And that is kind of intuitive, right? If I have like a metal, or I have like plastic, or if I have like, you know, wood, and then I want to heat them, it's kind of like their temperature, you know, it takes different times for them to, you know, heat up. Or if I have like water, for instance, in other, you know, all substances change temperature when they are heated, but how much they change for a given amount of heat varies significantly from one substance to another. So that depends on the characteristic or property of that substance. So something that is related to the substance itself, okay? And we want to quantify this thing that I just mentioned. So we use heat capacity. It's kind of like conductivity that one of your friends mentioned, right? You have like different conductivities for different matter. We use copper in wires because they have like high conductivity. We don't use iron, right? So depending on like different properties or like specific thing that we're looking for, we choose the element that suits that specific property. Does that make sense? Any questions? So one property can be, or is rather, heat capacity. And here we have like the definition. Heat capacity of a substance is the quantity of heat, usually in joules, required to change the temperature of a given amount of substance by 1 degree Celsius. So this is just how we define it. So we want to compare like water with iron and then see, you know, how much heat we should give to each of them to increase their temperature 1 centigrade degree. So to compare that, we use heat capacity. And when the amount of the substance is expressed in grams, the heat capacity is called the specific heat capacity, or simply the specific heat, and has units of joules per gram per degree Celsius. Because this is the amount of heat required to increase the temperature of a substance 1 degree Celsius, and increase, this amount is just for 1 gram of the substance. Because if I have 1 gram of water, or if I have 1 billion grams of water, this amount of heat would be different, right? That I need to give. If I had this room filled with water and I wanted to increase the water temperature by 1 centigrade degree, and if I had just a glass of water, so this amount of heat would be different, right? So we want to have a universal way to report it for different substances. So that's why we report for 1 gram. Any questions? So I have a table here. If I have lead, gold, silver, or if I have aluminum or ethanol, or if I have water, for each of these, if I warm them, if I give them some heat, all of them, won't get warm at the same time. Does that make sense? Okay, so in this table, again, I don't ask you the numbers to remember, but I expect you to notice the trends here and numbers and realize that water has the highest specific heat capacity compared to the other ones. So can anyone tell me, does that mean that if I'm having like the same amount of like water and gold, for instance, okay, I'm comparing these two. So which one I should give more heat in order to increase their temperature 1 Celsius? Yes? Water. So for the people who said gold, can any of you tell me why gold?
I'm not sure I understand yet, so I'll wait.
Okay, anyone want to? Yes?
I was thinking that if water has the highest heat capacity, it wouldn't take as much heating to get it to the same point as it would gold. Like gold would require more heat to get it to the same temperature.
Okay. So, anyone else wants to comment on this? Comparing gold and water? So you see, we have like specific heat capacity of water to be 4.184 joule per gram centigrade degree. So can anyone tell me what does this sentence mean? Yes?
It takes 4.184 joules per gram to increase the temperature of the water by 1 degree Celsius.
Yes. In other words, if we have like 1 gram of water and we want to increase its temperature 1 centigrade degree, we need 4.184 joules. Let me write this here. If I have 1 gram of water and I want to increase its temperature 1 centigrade degree, I should give it 4.184 joule energy. And remember dimensional analysis, using units to be able to solve problems, to guide you to solve the problems. So now I write the same thing. Can anyone, based on what I wrote here, if I can just manage this, I read here, right, like specific heat capacity of gold is 0.128 joule per gram degree Celsius. Can anyone tell me, based on what I just wrote here, what would be the equivalent for gold? Yes?
If I have 1 gram of water and I want to increase its temperature 1 degree Celsius, I should give it 0.128 joules per gram Celsius.
Exactly, but if I have like gold, right? So if I have like 1 gram of gold, so you write exactly the same thing here, I write it quick. If I have 1 gram of gold and I want to increase its temperature 1 centigrade degree, I should give it 0.128 joule heat, or like, let me just, heat or energy, right? Heat or energy. So comparing these two sentences, which one we should give more energy to increase its temperature?
Water.
Water. Is this clear now? So water, among the substances that are listed here, has the highest specific heat, it means that if we want to increase its temperature, if we have the same quantity of all these substances, we should give more heat to water. And after that is for ethanol. And we don't talk about it much in this course, but you realize these are because of the intermolecular forces that exist between water and ethanol compared to metals. So we don't talk about whys much in this lecture, at least, but I want you guys to know that among these elements, water has the highest specific heat, and if you don't study this and I give you in the exam, you probably think that gold or silver, copper, all of them, you think that they have higher heat capacity compared to water. Does that make sense? Any questions? And I also have the text written here. So water has the highest specific heat among the ones that we have here. So I can ask you in the exam. Because water has the highest specific heat compared to above mentioned metals and ethanol, the temperature of water increases more slowly. And the temperature of metals increase more rapidly. So if you think about it, it kind of makes sense, right? So metals are good conductors, right? So if you give metals, their temperature increases quickly, so you give them less amount of energy compared to water. But you should give more heat to water to increase its temperature. So it takes, its temperature increases more slowly. Does that make sense? Questions? Yes?
So, which is saying heat capacity, so you say water has a higher heat capacity?
Yes, exactly. I mean, compared to the ones that we mentioned here, but these are the ones that I'm going to ask you in the exam. And I'm not asking you to compare lead with gold, just like water, ethanol with the others. Kind of know that water has the highest, and then ethanol, and then the rest of the metals that is in this table. Great question. Any other questions? Oh, here, joules per gram per degree Celsius. Again, so now that we talked about specific heat capacity, can anyone tell me what was the unit of specific heat capacity? It was in the previous slide.
Joules.
Exactly, right? Remember, we use dimensional analysis as a way to solve our problems. If you remember the units of a specific heat capacity, and if I want to find the heat, and heat has a unit of joule, right? It's an energy. So how can I convert this quantity here to joules? Anyone? What if I multiply it by gram? I can get rid of the gram in denominator, right? What if I multiply it by degree Celsius? I can get rid of degree Celsius, right? So in general, heat equals mass multiplied by specific heat capacity multiplied by temperature change. So Q equals M multiplied by C multiplied by delta T. And even if you don't know the formula, as I wrote, over there, you can see that if you multiply specific heat capacity by gram by temperature difference, you can find heat. Any questions? I'm not sure if you guys, if you're not asking questions, is it you're just waiting for class to finish, or you're understanding the materials well and you don't have any questions? I don't know which one is this. Okay, so as I said, Q is the amount of heat in joules, M is the mass of the substance in grams, C is the specific heat capacity in joules per gram per degree Celsius. And delta T is the temperature change in Celsius. And usually in chemistry and most of your courses, the sign delta we used to show the difference. So delta T is like difference between temperatures. Good? No questions? Yes?
So, is there any reason why heat is Q? Does that stand for anything? The Q?
Oh, great question. Yes, I think it stands for, yeah, I mean, usually these are like, does anyone know? Q. Great question. I'll look into it. Yeah, usually things stand for something, whether it's like Latin root of something, or like whether it's like Hebrew root. If sometimes it's just like temperature is just T. So it's just like the beginning of the word, or like capacity we write C, or like mass M. I cannot think off the top of my head that what heat would represent, but I assume that it would be like some, root of the word, and I can look into it after class.
Cool. Yeah, I just didn't want to make sure it's not like a different unit or something.
Yeah. But as long as you know how to solve the problem, I don't ask you, how do we write heat, So if you have like, if you pass thermodynamic courses or like physics courses that you deal with like work, heat, all that, we usually denote work with W, and then like, potential energy, or like, potential energy with U, or like heat with Q, So, but, this is kind of like, as long as you can just write it heat, as long as you don't confuse it, I don't ask you what we call heat. Does that make sense? As long as you solve the problem. Great question. And then, as we said, the symbol delta means the change in. So delta T means the change in temperature. Any other questions? So, before I do attendance, I brought some questions that I saw for you all. And I was told by students that sometimes it's more helpful if I just like solve a problem as you're solving it, instead of having them in the slides. And I was trying to do that for significant figures or some other questions converting inch to meter, for instance. But now I want to do it more. So let's start with the temperature question. So Moscow temperature is 42 degrees Fahrenheit right now, based on what I found online. Report this temperature in Kelvin and degree Celsius. So, can anyone tell me how you would start solving this question? So I give you in the exam next week, and I expect you all to know how to solve this. Yes?
You could put the 47 degrees Fahrenheit in the Fahrenheit equation and solve for Celsius.
Exactly. And do you remember, or anyone remembers, the conversion between Fahrenheit and Celsius? Yes?
Isn't it minus 32 divided by 1.8?
Exactly. So, I myself, have like this formula memorized, because again, I'm more comfortable with degree Celsius. So I have like, okay, if I want to convert Celsius to Fahrenheit, I multiply it by 1.8 plus 32. But this is exactly equivalent to, degree Celsius equals, degree Fahrenheit minus 32. Remember from like mathematics that, the one that you want to find, we want to find, Celsius here. So we can like take like 32 to the other side, and then the sign changes, and then divide by the coefficient of Celsius, 1.8. Any questions about this? If you have difficulty with the math, just email me and I explain, more to you, or just like ask me now, or like your SI pass leaders or your tutors. I don't want any of you not knowing something. Okay? Or the other way to say that is that when we have an equation, we can deduct a number from both sides without the equation being changed, right? If I have like 10 equals 10, or rather, if I say 10 equals 20 minus 10, okay? If I add 2 to the both sides, again, 12 would be 10 plus 2, which is 12. Does that make sense? If you have an equation, you can add or subtract a number from both sides without the equation being changed. So meaning that I can deduct 32 from both sides without the equation being changed, right? So these two cancel out. And if I want to, again, in the equations, you can divide both sides by the same number without the equation being changed. So I can divide both sides by 1.8. So the result would be degree Fahrenheit minus 32 over 1.8 equals degree Celsius. Is this clear? Okay. So the temperature, I said that is like 47 degree Fahrenheit. So here I just substitute Fahrenheit in the equation and I get Celsius. So 47 minus 32 divided by 1.8 would be degree Celsius. And then when you put that in your calculator, the answer would be 5.56 degree Celsius. And I always encourage all my students to also check the number, roughly in their head. So you see like 47, minus 30. I mean, I guess literally you can, deduct these two numbers too, right? This would be 5, this would be 1, right? It's not that difficult. And then if I divide 15 by 2, it would be like 7.5, right? So your answer should be in this range. So this is like, you can trust a number from calculator, but if you get this number as 55, you know that this is off. Does that make sense? So always, and I write this here too, always check your answer. Or if you want, and this is the next step, you want to find the temperature in Kelvin. If you get a negative number, that would be not acceptable. So you laughing with the red hat, can you guide me how I can find it with Kelvin?
I was confused how you got that answer because most of us back here got 8.3.
Oh, anyone else got it? 8.3? Okay, let me see, what did I do wrong? Can anyone tell me what did I do wrong?
When you originally said the question, you said 42 degrees, not 47, but when you did the whole equation.
Oh, okay, so that's the thing. Yeah, thank you for mentioning that. Yes. Okay, yeah, I written in my notes 42, and and I have it 42 throughout, but for some reason I wrote. So would this be the same with 42? Can anyone confirm this? That is right? Okay. Yeah, thank you for mentioning that. Okay. Yeah, and this is, kind of like what happens in your exams too, that, you know everything, and then you just do what I did, put it in, you have 42, but you put 47, and you get the answer wrong. So, yeah, thank you for mentioning that. Okay, so now if I want to convert this to Kelvin, can anyone tell me how can I do that? Yes? Uh-huh. Exactly. Okay. And this is right? Okay, so we have 5.56 degrees Celsius plus 273.15. and hopefully I'm writing this correct, would be 278.71 Kelvin. Any questions? So in general, remember the temperature roughly is like 6 Celsius degree. It was like 5.56. And the original temperature was 24 Fahrenheit and degree Fahrenheit and 279 Kelvin. You see how the numbers compare? So the Kelvin is like numerically the largest number. And then, Celsius is kind of like the lowest. So if I have 0 Kelvin, the temperature that is lowest temperature and all the motion of molecules and atoms stop, that would be minus 273.15 degrees Celsius and would be minus 459.67 degree Fahrenheit. And you can just like do the math and then validate these results. Any questions? Yes?
When you're calculating the Celsius degrees, so the earlier equation, how do you know what to round to?
Okay. So the answer is, depending on how many significant digits you have. So here we have so we don't care about 32 or 1.8 because these are exact numbers. They have unlimited significant digits. So here we have 42. So our answer should actually have 2 significant digits. So I should write this as 5.6 degrees Celsius. But after, so in your exams and the rest of the semester, I'm not going to ask you to write the numbers with the right amount of significant digits because most students have difficulty with them. So I asked you, for your homeworks and quizzes, I asked you to round them to the correct number of significant digits. And for the makeup ones, today I also asked those. But from now on, I ask questions about significant digits separately. So even if you have difficulties with them, you don't have to worry about them. Does that make sense? But in general, you look at the reported number and then see how many significant digits they have and report the value with the correct number of significant digits. And great catch, thank you. Good? Okay, so let's see how much I can progress with the next question. Convert 110 pounds to ounce. And I'm going to write this here so you know. Pounds, that we show it with LB, to ounce, which we write it with OZ. Knowing the following information. 1 ounce equals 28.35 grams. 1 pound equals 453.59 grams. Okay, so remember, the thing that you want to find, you write a question mark with the unit of the thing that you want to find. What do we want to find here?
Ounces.
Exactly. So we write how many ounces equals the thing that is given, 110 pounds. Any questions so far? Is this clear? So this is the thing that we're using till the rest of semester. Any question that we want to solve, start with this. So I'm really emphasizing on this. Multiply by. So how can I directly convert pound to ounce? Am I given a conversion factor between these two? But what can I do? I can convert pounds to gram, right? So what should I write in the numerator? 453.59, right? What about denominator? 1. And these two cancel out. Any questions so far? Is this clear? Good. And again, I want to convert gram. What do I want to find? Exactly. And I can convert gram to ounces, right? What should I write in denominator? 28.35, right? What should I write in numerator? 1. And these two cancel out, and I have my answer to ounces. Any questions? So the answer would be 110 multiplied by this divided by 28.35. And it would be, when you put the number in calculator, would be something like this. And technically, you know, here, because we don't know how many significant digits this number has, remember, when we have trailing zeros at the end of a number before an implied decimal point, we don't know how many significant digits it has. So you can just write this number depending on how much you want to round it. So we don't know how many is uncertain, so you don't have to worry about it. And again, you know, I'm not going, when I give you questions about conversion factors from now on, I don't stress on significant figures. I ask you the questions separately from next week. Does that make sense? Okay. Any questions? So I'm going to write 2 questions really quickly and ask you to solve them because you're going to see them on the exam next week. One of them is the following. Density of butyl acetate is reported to be 882 kilogram per cubic meter. What would be this number in pound per cubic feet? And the other question is, knowing the following information, which is 1 foot equals 30.48 centimeter and 1 pound equals 453.59 gram. Oh, actually that was like, yeah, the rest continuation of this problem. So we know this information. Again, I don't expect you to know any number unless I tell you so. So I'll give you this information. And the next one, I have like this here so you can write it. My car's gas mileage is 25 miles per gallon in city. What would this number be in kilogram per liter? Knowing this information, 1 kilometer equals 0.6214 miles, 1 US gallon equals 3.785 liters. Any questions? What's that? Okay, zoom. Okay, is it good? Good? Okay. Oh. Okay, now let's do the attendance. And make sure to do the attendance because after class, if you email me that you were in the class, I don't accept that. So if you have a difficulty, just like raise your hand and I ask your name, or if you just should run to a class, just raise your hand so I ask for your name. And as I mentioned during the last class, I'm going to host your quiz, probably on Monday, because I want to have your exam would be till everything that we cover on Wednesday. Yes?
The link's not working for me.
Oh, okay, so raise your hands. So I'll come to you.
Okay, thank you.